The search for higher quality ride and handling is of paramount importance to motor manufacturers. Suspension parameter measurements that are both accurate and cost-effective are vital to design and development engineers. Anthony Best Dynamics personnel have been providing this service for some 25 years. The company also offers an unparalleled service in consultancy, design and development, with particular expertise in vehicle suspension, noise and vibration. The experience gained and the relationships developed with the world's leading automotive manufacturers has led to the design and development of the Suspension Parameter Measurement Machine, or SPMM. The basic philosophy behind the SPMM has been to design and develop a machine that is easy to use, with software that is flexible enough to allow a wide range of tests to be made, and a mechanical design that provides both reliability and a long life. The machine measures the quasi-static vehicle suspension characteristics that have a significant effect on ride and handling. These measurements are essential to the thorough understanding of the vehicle's performance in terms of ride, steering and handling. The data obtained is used to compare or benchmark vehicles, or to provide data to verify computer modelling of vehicle suspensions. It also provides the essential input data to dynamic modelling packages to assess the dynamic behaviour of the complete vehicle. To keep the testing time to a minimum, the standard machine tests all four wheels simultaneously, allowing the most commonly required tests to be completed in less than a day. A two-wheel station version of the machine can be supplied at a lower price. A full set of tests can be carried out by installing the vehicle forwards and then backwards. The two-wheel station SPMM is designed to enable it to be upgraded to a full machine at a later date. The standard machine comprises four main areas: the central roll, pitch, bounce table, the four wheel stations, the measurement system, and control and data collection software. Putting the vehicle onto the SPMM is a simple operation. The computer software prompts the operator at each stage of the procedure. Safety checks ensure that progress to the next stage is not possible until the operator has pressed a button to confirm that he has completed a stage. With track and wheelbase dimensions in the computer, much of the loading cycle is automated. The vehicle is automatically centered on the machine, and once the vehicle is clamped, the wheel stations are automatically centered beneath the wheels. The machine subjects the vehicle suspension and steering system to a variety of forces and displacements. It measures the kinematic characteristics due to the suspension and steering geometry, and the compliances due to the springs, anti-roll bars, elastomeric bushes, and component deformations. Driven entirely by electric servo motors, there is no requirement for hydraulics, which are noisy and prone to leak fluid. The SPMM employs a moving body concept, where the body of the vehicle is clamped to the central table, which can move in bounce, pitch, or roll. A wide variety of measurements are recorded by the SPMM. For example, in a bounce or vertical test, the loads on the tyre pad are measured, and the deflections of the wheels are measured. Similar measurements are recorded when the vehicle is rolled or pitched. To establish the horizontal plane compliances, Each wheel pad can be driven laterally or longitudinally, loading the suspension as in cornering or braking. The steering system compliances are measured by applying a torque at each wheel pad. Alternatively, the steering system can be driven using a specially designed motor drive to simulate driver input. A special test mode is provided which automatically combines the kinematic motion and the horizontal force inputs to more accurately simulate the cornering and braking behavior of the vehicle. As an option, the capability of the SPMM can be increased to provide accurate moment of inertia measurements. For these tests, the body of the vehicle is clamped to the roll, pitch, bounce table using special clamps and load cells. The machine runs through a sequence of tests, exciting the vehicle in roll, pitch, and yaw. The software analyzes the measurements and produces the full matrix of moments of inertia and the position of the center of gravity. The motion of the central table is controlled by 6 electrically driven roller screw actuators, providing the table with 6 degrees of freedom. There are 3 vertical actuators, 2 longitudinal and 1 lateral, all computer coordinated to ensure the motion is true. The positioning accuracy is extremely high, typically better than 0.1 millimeters. The wheel stations use linear roller bearings for both the lateral and the longitudinal motions. Motion is provided by precision ball screws, motor driven through toothed belts. A further motor below the turntable provides rotation about the vertical axis. At the heart of the wheel station is a multi-axis load cell, which can measure the 3 orthogonal forces and 3 moments applied to it by the tyre. A choice of piezoelectric or strain gauge load cells can be fitted, but we recommend using the piezoelectric device made by Kistler, which is sensitive to very small force changes even in the presence of high static loads from the suspension. The deflections of the road wheels, due to the tyre forces applied to them, are measured using digital draw wire encoders mounted on stands beside each wheel station. The encoders incorporate a precision spring-loaded spool with stainless steel wire wrapped around. As the end of the wire is moved, the spool rotates, taking with it an optical encoder. The output from the encoders is used to compute all 6 degrees of movement of the wheels, lateral, longitudinal and vertical, as well as changes in toe, camber and spin angles. These encoders have a high resolution, 0.01 millimeters, and have proved to be versatile and reliable. As an option, Anthony Best Dynamics can offer its dynamic arm, which can provide even greater accuracy and can measure at higher frequencies than the draw wire systems. Caster change can be measured directly by means of a servo inclinometer attached to the hub carrier. The servo motors driving the machine are controlled by a highly reliable, multi-axis programmable controller, which receives instructions from the Supervisory User Interface program designed to run under Windows. This program provides an easy-to-use, familiar user interface. A database is provided to store vehicle and test data. A new record is created for every vehicle tested. It stores basic information such as vehicle type, manufacturer, dimensions and suspension details, as well as important project-related data. The test specification contains all the information needed to run a test: cycle time, number of cycles, force or displacement limits, and type of control on each axis. A typical test takes 2 minutes, from which all results are stored in a separate binary file that's accessible for post-processing. During a test, results can be plotted in real time to give instant information on the progress of the test. The plotting program can automatically select the correct graphical display for each type of test from a set of stored plotting templates. The post-processing option allows automatic processing and plotting of results upon test completion. The graphical output and post-processing calculations can be customized to your requirements. A large number of parameters are derived from the measurements such as roll centers, anti-lift and anti-dive tangents, and steering system parameters. The control and management of the SPMM is flexible enough to allow your experienced operators not only to carry out existing tests, but also to devise new ones that suit your vehicles and your practices. The design of the SPMM allows easy access to view the suspension from below during a test, a useful feature for development engineers. The ease of access also enables some suspension components to be changed whilst the vehicle is installed on the machine. The SPMM can be installed either on the workshop floor using a standard vehicle lift to raise the vehicle up to the loading height, or in a pit that permits loading the vehicle at floor height. Anthony Best Dynamics have supplied SPMMs to vehicle manufacturers, Tier 1 suppliers and test houses in countries around the world. The suspension parameter measurement machine provides an essential tool for the motor industry worldwide.